Hello everyone. The title of this video is Recognizing Characteristics of Parabolas. Now each example, actually the only example I'm going to be doing in this video, is taken directly from a free online textbook at openstacks.org. I'm in their Algebra and Trigonometry text, section 5.1, titled Quadratic Functions, and I'm working under the heading Recognizing Characteristics of Parabolas. Alright, and as I said, each example is the only example I'm going to be doing in this video is taken directly from the examples in the reading here. Alright, so you got some reading to do. They talk about, the graph of a parabola, or a quadratic function on the xy plane, and point out some important aspects of it, some things you're going to have to identify in certain exercises as well. Alright, so the only example I want to do is example 1. Right, example 1. And I might show you a graph of another quadratic function after this. This one is a parabola that opens upward. I'll just make up some parabola that opens downward and show you that one as well. Alright, so maybe I'm doing 2 examples, but only one from the text here. Okay, so like I said, I want to do example 1 from the text. Let's go back and take a look at it. Alright, so we're asked to determine the vertex, axis of symmetry, zeros or roots, and y-intercept of the following parabola. Alright, so I want to talk about what all these words mean as well. What do they mean in relation to a parabola? Alright, so I'm going to make a rough drawing by hand of the following parabola here. Okay, so here's a very rough sketch, very rough, of what I saw in that example. So this lowest point, remember a parabola is a graph of a quadratic function. I'll write that up over here. And the parabolas we're going to be seeing for the most part in this chapter 5 of the Algebra and Trigonometry OpenStax textbook, are going to be parabolas that open up like this. The curve is opening upward or down. Alright, so a parabola is going to be some curve opening up like this or opening down like this. And the graph, this is just the graph of a quadratic function. Now the general form of a quadratic function is like, f of x equals a times x squared plus b times x plus c, where a, b, and c are, real numbers. Alright, now some points they're having us find here are the vertex. Alright, that's the lowest point or highest point, depending on which way it's opening. Alright, so there, this point here, this point 3, 1. Alright, 3 on the x, 1 on the y. This is the vertex. And like I said, I'll point out some key stuff about parabolas over here. So yeah, so the vertex of a parabola, this is the highest or lowest point. Depending on which way it's opening, right? If the parabola is opening up, it's that lowest point. If the parabola is opening down, like this, it's the highest point. Alright, then there's another thing they're asking us to identify as the axis of symmetry. Alright, all these parabolas are going to be symmetrical about some vertical line, and it's a vertical line that contains the vertex, and I'm going to dash it, make it a dotted line here. and this is at x equals 3, right? X equals 3, vertical line. And this is again called the axis of symmetry for this particular parabola. All right, so off to the side here, axis of symmetry. This is just vertical, for these parabolas that open up and down, this is just a vertical line containing the vertex. And we'll talk about how to easily identify the equation for this axis of symmetry in later videos. Alright, and hopefully you can see the symmetry. It's probably better on the, back on the website. And you can see the symmetry at x equals 3, how if you were to fold the graph along the vertical line x equals 3, the right half and left half would meet up. Right, or you can think of it this way too. Or you could think of it this way as well. Oops, sorry, let me go back here, check it out. Okay. If you were to be on any point, so like here's the point, 6 comma 7, that looks like it's on the graph, and then this point over here, right, is 0 7. If you go from the axis of symmetry, you go directly right and left. See, this is 3 units to the right, and then 3 units to the left. You're on the graph again. And it works that way for any point on the any pair of points on the parabola. If you go from one point on the parabola, you go to the axis of symmetry, right, directly to it, perpendicular to it, and then the same distance across, you land right on the parabola again. All right. So that's why this is the axis of symmetry. Okay. Great. So we got axis of symmetry is x equals 3. The vertex here is the point 3 1, right, the lowest point on this graph. All right, then we're asked to identify the zeros or the roots. Now, when they talk about zeros or roots of a quadratic function or any function, this is just the x-intercepts. X-intercepts. Where does the graph hit the x-axis? Well, you see this graph here doesn't hit the x-axis. So we would say that this function has, or this graph has no real roots, right, or no real zeros. Because again, there are no x-intercepts. This graph does not touch the x-axis. Now what you're going to notice is that, this is a degree 2 function, so it should have 2 complex zeros. We'll see all that stuff later, talking about the fundamental theorem of algebra. But we're going to see that for a function like this, where it doesn't hit the x-axis, all the roots, all the zeros, are going to have an imaginary part. They're going to have that number I involved. All right, but we'll get to that plenty later. All right. But for right now, I'm just going to say it has no real roots, right? No x-intercepts. And then the last thing they're asking me to identify in this example is the y-intercept. But, I'm not going to really write out what that means. This has been brought up in previous videos. The y-intercept of a function or a graph is just a point on the y-axis. So that would be 0, 7 here. Right? The point 0, 7 is just where, or you could say the y-intercept was 7. Right? You're just pointing out where the graph intersects the y-axis. Okay, so again, just some key points, key things to look for when looking at the graph of a parabola. what's the vertex, right? What's the lowest or highest point? And then what's the vertical line? You know, what's the line that kind of cuts the parabola into equal halves? Right? The axis of symmetry. Here it's x equals 3. What are the zeros or the roots? And basically the rest of it's what are the intercepts, right? Does it hit the x-axis at all? What are wherever it hits the x-axis, those are called zeros or roots of the function. You'll see both terms, both words throughout other videos and other reading. And this one has no real roots. And then y-intercept, easy enough. You know, when x is 0, where does the graph touch the y-axis? All right, now if I go back, I'm going to go back to the, I'll show you one more example where there's actually real roots, where there's actually x-intercepts. This is a website I've shown before. I'm sure you've seen this in previous videos of mine if you've been watching. It's called desmos.com. And I'm just going to put a quadratic function that opens down. So say negative x, it has to have a negative lead coefficient. Negative x squared, let's just go plus 9. Plus 4. So you can see the whole thing right here. Alright, so you see here, y-intercept 0, 4, and that's also the vertex. Alright, that's the highest point of this function. And it does have x-intercepts. So it has these real zeros or real roots of 2 and negative 2. Alright, it's crossing the x-axis at 2 and negative 2. Those would be called the real roots or real zeros of this function. And the axis of symmetry is just the y-axis here, right? Again, it's just x equals 0, right? X equals 0. It's just the vertical line, and I'll put that in. All right, might as well. X equals 0, and I'll make it like a dotted line here. Nice dotted line, and maybe an orange or something. Nah, let's go green. Yeah, Christmas colors. Alright, so you can clearly see that, you know, the graph is symmetrical about the y-axis here, the line x equals 0. And points on the right side are the same distance from this axis of symmetry as points on the left side. Okay. Great. So again, that was I just wanted to get one example in there where the parabola opened down. All right, and you'll notice that's when the lead coefficient, the coefficient on the x squared term, is negative. Right, when the lead coefficient's positive, right, if I change this to positive x squared plus 4, it's going to open up. See, opens up, and now there are no real roots, right? There are no real zeros. It doesn't cross the x-axis. So a simple change like that can change a lot of things. Okay, so I'm hoping you can identify the vertex, the axis of symmetry, the zeros or x-intercepts, the roots, and the y-intercept of a parabola if you are given the graph of a parabola. All right, and that is all I've got for you. So again, I'm hoping looking over this one example, a couple examples here with me in this video, help you out when you're asked to identify those things yourself, given the graph of a parabola. And thank you very much for watching.